right, let's get started. So I'm Delwyn Olivan. I'm a senior product manager here at AWS, and I'm joined by Victor Yap, a senior ML ops engineer at Rev. And we're here today to talk to you about getting started with Amazon FSx for OpenZFS. In terms of the agenda, we'll cover a few topics, but we're going to start with an introduction to the service, and then we'll deep dive into some of the specific features and capabilities that FSx for OpenZFS has to offer. And then we'll go into some of the use cases or how we're seeing customers use this service. And then we'll answer some common questions about getting started with FSx for OpenZFS before ending with a demo of some of the core capabilities of this service. And so we'll start with an introduction to the service itself. Ultimately, FSx for OpenZFS is a shared file storage solution on the AWS cloud. But why do customers use shared file storage? Well, it offers a simple experience. So the storage appears like local directories to your users and applications. It works natively with your operating system or the APIs. It offers shared access, meaning that it enables multiple users, computers, and applications access to the same data. It delivers really high levels of performance. So it enables, it's optimized and built to deliver really high throughput, really high IOPS, really low latencies to ensure that you're getting the most out of the compute capacity that you're provisioning on the cloud or on premises. And lastly, it offers really rich capabilities for working with your data. So things like snapshots, cloning, caching, all of this really are built into file systems and the file storage and uniquely enable you to work with your data in ways that you wouldn't be able to with standard block storage. And so with file storage being used for so many workloads, it's really no surprise that there isn't a one-size-fits-all solution or one-size-fits-all file system to meet all the needs. There are many file systems out there, and each of them really offers a unique combination of features, a unique combination of performance, a unique set of data management capabilities, and cost profiles. And as a result, if you have a workload running on an existing file solution, it can be really time-consuming and really costly to move to a new one. You'd have to re-architect your application, you'd have to re-platform, you'd have to re-qualify. And these are all things that are costly and really slow down your ability to move to the cloud and innovate faster. And that's why we launched the FSx family of services. And with the FSx family of services, we really aim to offer a seamless path for migrating your applications and your underlying file storage to the cloud so that you can lift and shift your existing solution to fully manage file storage without having to re-architect, without having to re-qualify, and without having to rewrite any of their existing code. Within the FSx family, we offer 4 different offerings. So we have 3 scale-up file systems, FSx for NetApp ONTAP, FSx for OpenZFS that we're talking about today, and FSx for Windows File Server. And we have 1 scale-out or parallel offering called FSx for Lustre. And combined, these really enable you to launch, run, and scale feature-rich, high-performance, cost-effective, and fully managed file storage. And it really enable you to accelerate your cloud adoption for virtually any Linux, Windows, or Mac-based workload. And the reason I'm here today is to talk to you about FSx for OpenZFS. It's the most recent addition to this FSx family of services. And I'm extremely excited to tell you about what it is. So it's simple and cost-effective high-performance NFS shared storage that is built on the AWS Graviton family of processors, and as its name suggests, the popular open source OpenZFS file system. So what is the OpenZFS file system? Why did we choose to build this service on top of it? It's an advanced, powerful file system that's purpose-built for high performance and scale. And what that means is that it has efficiency and performance features embedded in its foundation. So things like a copy-on-write architecture that powers some of the unique snapshots and cloning capabilities that we'll talk about shortly. Things like integrated data resiliency, so checks and balances that automatically flag any data issues proactively if they are to occur. And dedicated caching. So whereas most file systems leverage the same cache that's built into the operating system, ZFS has a dedicated cache that offers really fast performance for your frequently accessed data. And this cache is dedicated in that it's built into the file system layer, meaning that ZFS uses this cache really aggressively to make sure that we're delivering the highest levels of performance. So, of course, OpenZFS is a really advanced and powerful file system, but you might wonder why more customers aren't using it today. Well, there are, of course, some challenges around working with OpenZFS, and there are some things that you might have heard about the file system. It can be complicated to set up and configure. It can be difficult to tune for the best performance. It can be hard to maintain and operate. And frankly, some people think that you need to be a ZFS expert to even get started. Well, with FSX for OpenZFS, we aim to offer all the power of ZFS without any of that complexity. So people say it's complicated. You can launch and scale a ZFS-based file system in minutes. People say it's difficult to tune. We offer pre-tuned configurations and storage and performance scaling on demand. People say it's hard to maintain. Well, we offer automatic backups and maintenance and automatic replication and recovery of your data. People say you need to be a ZFS expert. Well, with FSX for OpenZFS, all you need to worry about and all you get is a simple, fully managed NFS endpoint. So why should you use FSX for OpenZFS? There are really three categories of usage and capabilities that we see. FSX for OpenZFS delivers really high performance storage for latency sensitive and IOPS intensive use cases. It provides a cost-effective, fully managed drop-in replacement for your existing self-managed NFS servers. And lastly, it provides advanced ZFS capabilities for working with data, made simple and easy via the AWS console and the FSX API. So we'll dive into each of these three areas individually, starting with the first one. So how do we offer this level of performance? Well, ultimately, one of the benefits of building here at AWS is we get to benefit from all of the innovation that's happening here at Amazon, all of the innovation that's happening here at AWS. FSX for OpenZFS is built on the latest AWS Graviton family of processors. It's built on the AWS Nitro system, and it leverages SRD, or Scalable Reliable Datagram technology, to really deliver high levels of price performance and really low consistent latencies for your data access. So when it comes to file storage, there are really three dimensions that customers care about. There's latencies, there's IOPS, and there's throughput. So let's start with the latencies. With FSX for OpenZFS, you can get latencies of just a few hundred microseconds for your frequently accessed data. But what does that mean for you? I think this statistic in and of itself really undersells the point. Not only are these latencies almost an order of magnitude better than what you can get from other cloud providers, when you look at the performance that this delivers compared to a do-it-yourself, self-managed file system that you would have to manually set up, manually configure, and manage on an ongoing basis, we can deliver the same result 3 times faster at the same cost of your do-it-yourself file server. And in terms of IOPS and throughput, we are able to deliver up to 1 million IOPS and up to 12.5 gigabytes per second of throughput. And when we make the same comparison to that do-it-yourself file system, we're able to deliver 4 times the IOPS in that file system that you'd have to, again, set up, configure, and maintain, all at the same cost. And the second area that I mentioned was around being a drop-in replacement for NFS file storage. And what does that mean? That means that we offer the ability to access your data using the same NFS protocol that you're used to today, and from virtually any environment. So we support all major versions of NFS, NFS v3, v4, 4.1, 4.2, and in doing so are able to support a broad set of clients, including Windows, Linux, Mac OS, across a variety of compute end containers, including Amazon EC2, ECS, EKS, Workspace's AppStream. and across a variety of different network configurations, either within AWS or between on-premises and AWS, leveraging technologies like Direct Connect. Not only is this a drop-in replacement for your NFS file storage, it also is an extremely cost-effective replacement for your NFS storage. In addition to offering really low, compelling pricing, there are cost efficiency features embedded into the offering itself. So we offer storage and performance scaling with the click of a button, and we offer multiple data compression options to reduce your storage footprint by up to 50%. And what that translates to is an all-in effective cost for high-performance SSD storage of less than 6 cents per gigabyte month. And you are able to also customize the amount of storage and amount of performance independently so that you can really fine-tune your deployment for your workload. That storage comes at a cost of 4.5 cents per gigabyte month, and the throughput or performance comes at a cost of 26 cents per megabyte per second month. And the third area was around ZFS capabilities made easy. What are those ZFS capabilities? The first is the ability to divide your file system into multiple data containers called volumes, which enable you to easily set up multi-tenanted SaaS applications, all powered by a single file system. You can also take point-in-time snapshots of your data extremely easily to enable rapid testing of new features or database changes, and the ability to roll back individual files or folders to past historical versions. And we also offer in-place data cloning, all powered by ZFS. And with data clones, you can power parallel virtual machines, user environments, all with a shared data set, so you can be both fast and space efficient with how you're powering multiple parallel environments. And so how are customers using FSx for OpenZFS? Across these three areas, we're seeing a broad spectrum of data-intensive and general purpose usage. With respect to high-performance storage, we're seeing use cases like quantitative portfolio optimization with tick data, front-end chip design that really needs high-performance storage for temporary files generated with these chip design workflows. We're seeing customers use FSx for OpenZFS for streaming video processing, and where the low latencies are really beneficial for live processing of live video feeds. And we're also seeing customers use the IOPS intensive storage to support genomics research across large HPC clusters. With respect to drop-in replacement for NFS, we see the general purpose user shares and home directories. We see a lot of customers using FSx for OpenZFS for that usage. And we also are seeing a lot more customers leverage FSx for OpenZFS for a simple shared storage solution that supports both Windows and Linux clients. And then with these advanced ZFS capabilities, we're seeing a lot of customers build efficient virtual machine storage and power parallel database environments, all using a single file system to really optimize their costs. All right, but don't take it from me. I'd like to introduce you to Victor Yap, a senior ML ops engineer at one of our customers, Rev, to tell you about their experience working with FSx for OpenZFS.
Yeah, thanks, Darwin, for the introduction. So my name is Victor Yap, and I'm a senior ML ops engineer at Rev. Rev is a job marketplace for professional transcriptionists and captionists. Rev helps customers transcribe their audios and caption their videos with the largest community of speech-to-text professionals. But another area of focus for Rev is also in building industry-leading automatic speech recognition, or ASR models. We use these models to generate drafts for transcriptionists, as well as serve these models through an API to customers who have higher volume or just require higher turnaround times or lower turnaround times. So on the next slide, I'd like to talk a bit about building these ASR models, some of the challenges we faced, and how FSx for OpenZFS helped us. So some of the context: first, Rev is not an infrastructure company. We rely on AWS for all of our compute needs. And we also needed shared storage that was low latency for data processing and model training. For example, we might launch 100 instances to process a new data set, all hosted from the same place. So we solved this need at first for shared storage by managing our own NFS server. But as our team and projects grew, so did our usage. And soon, quickly, this self-managed NFS server became a single point of failure, and any disruptions to it just affected the whole team. If ever the NFS server was not responding, then no one could really make progress on data processing or model training. And overall, it was just not a great experience. We kind of continued like that for a while until we saw that FSX for OpenZFS was announced. And at first look, it looked like the best service to replace our own self-managed NFS server. And once we started doing that, it took some time to move all of our data, but updating configurations was very easy. So since switching, we have spent much less time managing the shared storage. We also lowered our cost by 30% and increased our throughput by 70%. And we have improved visibility thanks to CloudWatch metrics, so we can see spikes in our usage that we didn't have visibility in before. Again, because Rev is not an infrastructure company, we probably weren't that optimal with our own NFS deployment, which is why we see these cost savings and performance improvements. So overall, switching from our self-managed NFS solution to FSX for OpenZFS has really helped us focus more on building models instead of focusing on infrastructure and operation costs.
Awesome. Thanks, Victor, for sharing your story with us. It sounds like exactly what FSX for OpenZFS was designed to help with. So switching gears, I'll talk a little bit about some of the common questions we get as customers are getting started with this service. The first is, how do I migrate my data to FSX for OpenZFS? The second is what kind of performance can this file system deliver? The third is, how do I use or what are snapshots and clones? And the last is, with 4 different offerings in the FSX family, how do I really choose between these different services? So how do I migrate my data to FSX for OpenZFS? Well, we really have 2 core options for migrating your data into this service. And here I'll illustrate an example based on migrating on-premises storage into AWS. On the left is your on-premises environment where you have an existing NAS solution. And on the right is your FSX for OpenZFS file system. The first option is to leverage a fully managed service like AWS DataSync. And in doing so, you need to set up data sync agents in your on-premise environment, and it offers a fully managed data replication to your FSX for OpenZFS file system. It's fully managed, so you don't need to worry about setting up any connectivity or any individual clients. You can set up periodic replication that's completely incremental, so you can maintain these 2 environments. You can synchronize these 2 environments continuously prior to your cutover time, and it's really fast in that you can transfer up to 100 terabytes per day per data sync task, and even parallelize multiple tasks to deliver even higher levels of overall throughput. And the second option is a do-it-yourself option. You can also copy your data from your on-premises file storage by mounting your on-premises storage and your FSX for OpenZFS file system onto a common EC2 client, and then use standard copy tools like rsync to copy large quantities of data between the source and the destination. We recommend that most customers use AWS DataSync to benefit from the fully managed service and to really deliver the highest levels of speed and convenience for their data transfer. The second question was around the performance. So we talked a little bit about the levels of performance that FSX for OpenZFS can deliver. What I'd like to do is dive a little bit deeper into the different dimensions of that performance. So your FSX for OpenZFS file system, as illustrated in the diagram on the top of this slide, is made up of a file server and a set of durable persistent disks attached to that file server. So whenever clients access data from your OpenZFS file system, that data can be delivered either directly from the file server, so the in-memory cache on that file server, or it can be delivered from the disks attached to that file server. And because the data that's accessed from cache travels a much slower, much shorter distance, we're actually able to deliver higher levels of performance for that data versus the data that needs to be read all the way from disk. So the way to think about it is your frequently accessed data will typically live in your file server's in-memory cache. So we're able to deliver higher levels of performance for that frequently accessed data, whereas your infrequently accessed data, or the rest of your data, will typically need to be accessed from disks, which deliver a lower but still very high level of performance. So as I mentioned earlier, there are really three dimensions to file system performance. There's latency, there's IOPS, and there's throughput. With respect to latencies, which are really the how much time it takes to return the first byte of data, when you're accessing data from in-memory cache, FSX for OpenZFS can deliver latencies of just 100 to 200 microseconds. And when you're accessing data from disk, it can deliver latencies in the order of 300 to 500 microseconds, so under half a millisecond. And then there's IOPS, which is the number of operations that we're able to deliver per second. And when you're accessing data from cache, we're able to deliver up to 1 million IOPS, and you're accessing data from disk, we're able to deliver up to 160,000 IOPS. Both latency and IOPS are really important for transaction-heavy, often sequential applications like front-end chip design workloads, machine learning that leverages a lot of small files, so things like audio, like what Victor at Rev, their company does, and even simple applications like code repositories, content management. These types of applications really do benefit from low latency access to your data. And then the third dimension is throughput, of course. It's the total amount of data that can be transferred per second. And when you're accessing data from cache, FSX for OpenZFS can deliver up to 12.5 gigabytes per second of throughput, and from disk can deliver up to 4 gigabytes per second for throughput. Throughput is important more for scalable data-intensive workloads like data and analytics and machine learning with large files, where ultimately it's just about how much data you can move through the pipes. So the third area I wanted to dive a bit deeper into is what are snapshots and clones. So snapshots are instant point-in-time historical snapshots, for lack of a better word, of your data that live on your FSX for OpenZFS file system. What they enable you to do is compare to previous versions of your individual files or folders, to undo changes to those individual files without having to restore the entire volume or the entire file system itself. Meaning that your end users and even your applications can self-service access to these historical versions. And clones, on the other hand, or clone volumes, are really fast and space-efficient data containers that are built on top of these snapshot capabilities. What they enable you to do is to test multiple changes in parallel. So you create clones from the source snapshot data, and these clones are isolated both from the source data, in that any changes to these clones don't affect the source. And they're also isolated from each other in that any change to an individual clone, any change made to that data, does not affect other clones that even share the same source. And what they enable you to do in terms of benefits is to really save time in that you can spin them up nearly instantly and reduce costs in that they eliminate the need to store duplicate copies of your data to support parallel users, parallel applications that are really accessing or using the same data for their use cases. And there are two specific use cases I wanted to dive into. So one is around using clones for efficient virtual machine storage. So without cloning, in order to power 4 virtual machines, each with a terabyte of data, what you typically need to do is store 4 duplicate copies of this data. In total, you need 4 terabytes of storage in order to power these 4 virtual machines. But in fact, a lot of these types of environments share a lot of data across these end users. So common data like the operating system, shared applications, they really make up the majority of that terabyte. And what cloning enables you to do is to store that common data only once, and then create individual clones that power each of those individual user environments. And what these clones are really doing here are making sure that any of those end users' changes or activity aren't affecting any of the others. And these clones are really storing those incremental changes. So the individual data files that are being created or the individual user settings that are being changed, these are stored in isolation. But of course, because the bulk of the data is common, you're able to power the same number of end users using a quarter of the storage. And you can see how this savings or this efficiency will only increase as the number of users, number of applications increases. And so another use case for cloning is for efficiently powering multiple dev and test environments. A lot of enterprise applications leveraging database data like CRM or ERP applications can require up to 20 different environments. And typically this would require you to duplicate your data just as many times. This is time consuming, it's error prone, it's inefficient. With FSX for OpenZFS cloning, you eliminate the need to create these copies, saving time and reducing cost. Here, we highlight an example from a recent blog post on how you can use clones with Oracle databases, but this configuration could work for almost any data serving setup. On the left, you have the primary host, which is powered by EBS storage. And on the right, you have the standby host, which is powered by FSX for OpenZFS storage. Most of the time in these types of Oracle database active-passive configurations, the standby host is actually idle, standing by, as the name suggests, in case any event affects the availability of the primary host. In this setup that we illustrate here, you're actually able to use the standby host for productive use, using it to power your parallel dev, test, and standby environments. In the bottom circle, you can see that on the standby host, we're running the standby database, the dev database, and the test database. And in the right circle, you can see the storage configuration that is powering those database environments. The standby database is powered by the standby volume that is on the FSX for OpenZFS file system. And the dev and test database are actually powered by dev and test clone volumes that are created from that standby volume. To any end users, these standby, dev, and test databases will look and act and feel like completely independent database environments. But with FSX for OpenZFS cloning, the dev and test databases are actually powered by the same storage as that standby database. And for you, what that means is that you can, one, support multiple environments with the same storage, meaning that you can significantly save costs. And two, you can synchronize your data across these environments a lot more quickly and a lot more easily, meaning you can innovate faster with that data. So the last question I wanted to cover was, how do I choose between the different FSX offerings? So we have 4 offerings in the FSX family. We have FSX for NetApp ONTAP. We have FSX for OpenZFS. We have FSX for Windows File Server, and we have FSX for Lustre. And it really comes down to 2 core questions. The first question that we start with, and I'd say 80% of the time, this is all we really need, is what are you using today? If you're using NetApp ONTAP or other NAS appliances on premises, then you should choose FSX for NetApp ONTAP. If you're using ZFS or other Linux-based file servers, then you should choose FSX for OpenZFS. If you're using a Windows Server-based file server today, then you should use FSX for Windows File Server. And lastly, if you're using Lustre or other parallel file systems, you should choose FSX for Lustre. If you're building a net new workload, instead of migrating from an existing storage solution, then there's a more nuanced conversation around the specific features and performance and capabilities that your workload needs. And there are really 4 dimensions that matter here. There's performance, accessibility, availability, and storage options. With respect to performance, FSX for OpenZFS delivers the lowest latencies and delivers up to 1 million IOPS. So you should choose that if you're looking at a particular latency sensitive application, whereas FSX for Lustre delivers up to 1 terabyte per second of throughput and multiple millions of IOPS. So you should choose FSX for Lustre if you really need hundreds of gigabytes per second of throughput at that scale of data for your workload. With respect to accessibility, we support multiple different protocols across these file systems. FSX for NetApp ONTAP has true multi-protocol support if that's what your workload demands. FSX for OpenZFS supports NFS, FSX for Windows File Servers, and SMB protocol, and FSX for Lustre offers a custom POSIX compliant protocol for parallel access. And in respect to availability, FSX for NetApp ONTAP and FSX for Windows File Server both offer multi-AZ offerings for high availability types of deployments and production use cases. And then with respect to storage options, FSX for NetApp ONTAP uniquely has a capacity tier storage for a low cost of 4.38 cents per gigabyte. And then FSX for Windows File Server offers an HDD offering, or hard disk powered deployment in the range of 1.3 to 2.5 cents per gigabyte, depending on whether it's a single AZ or multi-AZ deployment. And then FSX for Lustre offers a unique capability to auto import and export data from S3, enabling you to use FSX for Lustre as a fast file cache layer in front of long-lived cold data that you store in S3 storage. And so with that, I'll shift gears and do a bit of a demo on specific capabilities. So I'll cover 3 areas. The first is just getting started, how easy it is to create and mount a new FSX for OpenZFS file system. The second is performance, so I'll demonstrate how you can drive up to 12.5 gigabytes per second and the million IOPS per file system that we mentioned earlier. And then I'll cover some of the ZFS capabilities. So I talked a little bit about snapshots and cloning via the AWS console and FSX API. I will show you exactly what that looks like and what it means to actually use these capabilities. All right, so we'll start off by showing you just how quick and easy it is to create a new FSX for OpenZFS file system. You can see here we're navigating through the AWS console and choosing FSX for OpenZFS. And we have 2 options. We can do a quick create, and here we're going to create a new file system called quick. And all you need to input is the storage capacity you need and select the subnet that you want this file system to be created in. When you hit next, you get a summary of the configuration that you're getting, as well as information on which of these different settings are going to be editable after the creation. And this is really a way to quickly get up and running with the default settings that we recommend for most users and most applications. You can see here that it's in creating, and in about 3 minutes, this file system will be ready to run. So I'll switch over and walk through the full or the standard create experience, where you can really design for more advanced users. You can configure each of the individual settings on this file system. So as before, we provide the storage capacity that we need for this file system, but we can also choose the number of IOPS that we want provisioned, in addition to the automatic 3 IOPS per gigabyte that is provided. And we can also specify the throughput capacity of this file server. So we're able, by default, and in the quick create experience, we get 64 megabytes per second, but we're able to provision up to 4,096 or 4 gigabytes per second. As before, we select the subnet of the file system. And in addition to those settings, we're able to customize different parameters on the root volume, which is the primary data container that lives on that file system. We're also able to set up the backup and maintenance windows, and by clicking next, we'll get the same summary as we did before that shows all of the different configurations that we had just set, as well as which ones of those are going to be editable after this file system is created. I hit create, and you'll see both of these file systems are still in creating, but within a few short minutes, they will be up and running and ready to use. So the second area I wanted to demo was the performance that you can drive with this file system. So we're going to start just by mounting this file system using NFS v3 and using NConnect, which enables you to split up your connection into 16 individual connections to maximize performance. And we'll start with a simple test of single client throughput. We're going to use the ODirect setting here to ensure that all of that data is served from disk. And as we had highlighted earlier, we can expect up to 4 gigabytes per second, or around 4 gigabytes per second from disk. And what this test actually highlights is that we're able to deliver over 4.5 gigabytes per second with a single client from this FSX for OpenZFS file system. So the next test we'll run is a single client throughput test again, but this time without the ODirect setting to really drive that data access from cache. So you'll see we're going to run this a few times and take the average of the performance that we get. And here we should expect something on the order of about 12 gigabytes per second, as we had alluded to earlier in the presentation. And here we're able to deliver over 11.5 gigabytes per second, all with a single client that's mounted this file system. So to see how this scales with multiple clients, we'll use two EC2 clients and mount the same file system with the same NFS v3 and the same NConnect settings. And we'll see what type of scale we're able to deliver. With the same test, we're able to deliver nearly 5 gigabytes per second across these two clients. And then as before, we're going to rerun this so that we're reading that data from the in-memory cache on the file server. And you can see combined across these two clients, we're able to deliver over 12.5 gigabytes per second of total throughput. And now to test the number of IOPS that we're able to scale to, we're actually going to use 6 clients, all with the same NFS v3 and NConnect equals 16 setting, and see what level of total IOPS we're able to deliver from this same file system. And you can see as we aggregate across these 6 clients, we're able to deliver over 1 million IOPS from that same FSX for OpenZFS file system. So next, I'll demonstrate some of the snapshot capabilities that FSX for OpenZFS can offer. On the left, we have the AWS console. You can see I have a file system called demo. And on this file system, we have the root volume that's automatically created, the primary data container that lives on your file system, as well as another volume called baseline that we created within that root volume. And these will really just appear as simple local folders on the EC2 instance that you mount this file system to. On the right, we have an EC2 instance that has already mounted this file system. You can see it's mounted in the demo/FSX location where we're presently located. And it automatically has both the FSX, so the root volume, as well as that baseline volume that you saw in the console on the left. If I go into that baseline volume, it'll appear just as any other folder, so I can ls and see what files are in there. You can see there's a file called random big file that's 10 gigabytes, and then another file called temp that is 7 bytes, so rather small. If I cat that file to see what's in it, it says hello and an exclamation mark. So I pre-created this file for this demo. And what we can do is we can go into this baseline volume in the AWS console, and we can take a snapshot of this data, which really freezes the data in a point of time and enables us to look back at this file even after we make any changes to it in the future. So I'm taking a snapshot, and if I hit refresh, and you can see here the snapshot is available, so we have that point in time frozen and stored on the file system. And we can go back to the EC2 instance that's mounted that file system and start making changes to this data. So let's add something to that same temp file. We'll add goodbye to the end of this temp file. And you can see that if I cat that file, both of those words show up. And so there are two ways that FSX for OpenZFS enables you to roll back this data. You can go into the snapshot directory and see that snapshot that we just took and navigate within it as if it were any other folder on your EC2 instance. I can cat that temp file. You can see it's the historical version that didn't have the goodbyes string attached to it. And I can also, instead of restoring or looking at individual files or folders, I can decide to restore that volume to that snapshot state in its entirety. So you can see here in the console, I click Restore Volume under the Actions tab. I hit Restore, and within just a few seconds, that file system is back to its restored state. If I go back to the console on the right, you can see if I cat that temp file again, the one that had the goodbye attached to it, now that I've restored it back to that historical snapshot, nothing's been interrupted, nothing's been changed, but it now has been restored to that previous version that had been stored in that snapshot. So the last time I wanted to do is show how easy it is to use cloning with your FSX for OpenZFS file system. On the left, you can see we have the same demo file system. It has the baseline volume and the root volume. On the right, the same EC2 client that has this file system already mounted. And now what we can do is we can create a clone of that baseline volume. I'm going to call it clone. I'll turn off compression just for convenience. And then all I need to do is indicate that baseline volume as the source for this new volume that I'm creating. As part of this process, it automatically takes a snapshot to freeze that volume in a point of time when creating this clone. And in just a few seconds, we'll see that this clone is already mounted on the EC2 instance that we have on the right. Just hit refresh. And just hit refresh, and there it's available. And I can go back to the EC2 instance that had mounted this file system. And if I ls, the clone volume is there. I can ls the baseline, I can ls the clone. You can see both the random big file are in both of those directories. But if I go into the monitoring tab of the file system and look at how much storage capacity we're using, you can see that under the available storage capacity, in the time that I created that clone, it didn't change at all. So that clone, it took no additional space on the file system upon creation. That 10 gigabyte file did not need to be duplicated or copied. And what we have is a completely independent container for working with the data that's shared between the baseline and the clone. And what I can do is I can go back to the client. I can make a change to this temp file as I did before. So first I'll cat them both and show that they both just contain the same hello text. And I'll add a does this change affect the source text to the clone, the temp file. And if I cat the baseline, if I cat the clone temp file, it's there. If I cat the baseline temp file, you can see that that change did not affect that source data. So we have two independent data containers storing like 10 gigabytes of data, but we didn't have to duplicate that data, and the changes that we're making to that clone are completely isolated from the source, meaning that you can really quickly run new experiments, you can power multiple parallel environments really easily and efficiently using the ZFS cloning capabilities that FSX for OpenZFS can deliver. And just to recap, so why should you or why should customers use this service? It offers high performance storage, which means latencies of just a few hundred microseconds, up to 1 million IOPS, up to 12.5 gigabytes per second throughput. It's a cost-effective, fully managed replacement for self-managed NFS. It supports V3, V4, all for low effective costs of less than 6 cents per gigabyte month. And lastly, it offers the power of ZFS with just a few clicks in the AWS console. And so I wanted to close with a few thoughts on how you could get started. first, you can learn more. You can visit our product overview page on the AWS website, or you can take the on-demand FSX for OpenZFS workshop on GitHub, where we guide you through a couple of common workflows for working with FSX for OpenZFS. Second, you could roll your sleeves up and just try it out for yourself in the AWS console. As you saw in the demo, you can create an FSX for OpenZFS file system in just minutes. And you can also automatically attach these file systems to EC2 instances that you create in the new EC2 launch experience. And with that, thank you all for joining us today on the Tech Talk for getting started with FSX for OpenZFS. Victor and I both really appreciate the opportunity to share with you all of the exciting things happening with this new service. Thank you.